Hi, this is Andrea Hendricks. The topic of this video is using radian measure. Well, what do we mean by measure? We're talking about there the measurement of an angle, and we define the measurement of an angle to be the amount of rotation from the initial side to the terminal side. We can measure angles in two ways, one that you're probably most familiar with, and that is degrees, and another way that we're going to learn and really probably use most often is radian measurement. So let me review some common angle measurements that are in terms of degrees. Like if we have 90 degrees, 45 degrees, 180 degrees, 360 degrees. Let's talk about how would you represent those measurements on this Cartesian coordinate system. So to do that, let's say that we have a 90-degree angle. Well, a 90-degree angle is if we rotated our angle from the initial side, remember that's the x-axis, to the y-axis. If we made that rotation, that would be a 90-degree angle, right? Because the 90-degree angle is just simply a right angle. What about 45-degree angle? Yeah, 45 degree means that we're going to rotate it halfway between the x-axis and the y-axis, so just approximating here, that would be a 45-degree angle. You could certainly use a protractor and get this very precise. 180 degrees would be if we rotated from the initial side fully back around to the other part of the x-axis, so that would be 180 degrees. And what about a 360-degree angle? Yeah, 360 is if we rotate it from the initial side all the way back around to where we started. A full rotation of the circle would give us 360 degrees. So one thing to notice here is that whenever we have positive degree measurements, we're always moving in the counterclockwise direction, which we talked about that earlier. What if I wanted to draw a negative 60 degrees? What would that look like? Okay, then I have to start at what? My initial side, but now I'm going to move in the clockwise direction 60 degrees. So that would look like something like this. Now understand, angle measurements can actually go from truly, negative infinity to positive infinity. You might not ever get to that, but you can make more than one rotation around the circle, and so that's where we get to be greater than 360. So like for instance, if I wanted to go 2 full rotations around the circle, that would take me to an angle that has 720 degree measurement. Okay, so just keep in mind that you're not really thinking in terms of from 0 to 360. We can go in the negative direction, and we can go more than one time around the circle in both the positive and the negative direction. So we can really talk about any real number being an angle measurement in terms of degrees. Now let's talk about another way to measure angles, and that is radians. So to talk about radians, we have to talk about a central angle, and this is a symbol for theta. So we have a central angle theta, which basically means that its vertex of the angle is at the center of a circle. When the length of the arc, so the length of the arc is this distance right here, when that arc length that's cut by the angle, so if you could think about, here's our initial side and our terminal side, if we could cut out this amount and measure it, if this arc length has the same value as the radius of the circle, then we say that theta is 1 radian. So if S is equal to R, then we say that theta is 1 radian. So theta is 1 radian when the arc length is equal to the radius. So if we ever want to find out what theta is. Here's the formula. Theta will always be defined as, and this is a really important formula, the arc length, S, divided by the radius, right? We want to figure out how many times the radius goes into that arc length. If the arc length is exactly 2 times the radius, then we have a theta, a value 2 radians. So if you think about, if this is the length of the radius, we could move that around the circle. So what would an angle of 2 radians look like? And I'm not really drawing the scale here, but 2 radians would look like something like this, okay? And 3 radians, you could continue around. So 3 radians would mean that the angle intercepts an arc that has a length of 3 radii, or 3 radians, right? I mean, it is basically a copy of 3 radiuses, that's really not the right word, 3 radii around the circle. And I could continue around. It actually turns out that there are a little bit more than 6 radians in a circle, and I'll show you that specifically. Because if we wanted to figure out how many radians was in a full rotation of the circle, well, to figure that out, theta then, so we're thinking about, we know in terms of degrees that's 360 degrees, right? So we're looking at, if I make a full rotation of the circle, what is the value in terms of radians of that angle theta? Well, we know that the arc length, when we have a full rotation of the circle, the arc length is just a perimeter of the circle, right, or the circumference of the circle. Circumference of a circle is 2 pi r, and then we divide by the number of radii that are in that, divide by r, and we find that when we have a full rotation of the circle, the angle is 2 pi radians. Now we typically don't write the word radians. If you just see a number in terms of a measurement of an angle, then we just take that to mean radians. So, well, what is 2 pi? If we use the approximation of 3.14, 2 times 3.14 is 6.28. So that means that one rotation of the circle is approximately 6.28 radians, or 2 pi, which means that there are a little bit more than 6 copies of the radius along this circle. Now, some important things for you are going to be knowing some of the common angles in terms of radians. But before we get that, let's just think about this relationship, okay? So we know from what we just talked about that 360 degrees is going to be what? 2 pi radians. Okay? Now, if we divide by 2 to be 180 degrees, which is half of a rotation of a circle, well, if we take half of 2 pi, we just get pi. So 180 degrees is equivalent to pi radians. Well, if we divide in 2 again, we would get 90 degrees. So 90 degrees is equivalent to pi over 2 radians. Now if you divide this by 2, again, we would get 45 degrees. If we divide pi over 2 by 2, we get pi over 4 radians. Okay. Let me go back to the 180 and divide it by, since it's divisible by a few other numbers, let's say we divide it by 3. 3 into 180 goes 60 times, right? So if we divide pi by 3, we would get pi over 3 radians. And another one that's common, if we divide 180 by 6, that would be 30 degrees, and pi by 6 gives us pi over 6 radians. So it's going to be important to remember the relationship between these angles. So let's say if I wanted to draw some of these angles, so let me go to my line here. So if I wanted to draw an angle that is 180 degrees, or rather pi radians, I would start from my initial side and have a rotation of pi radians, which would take me to the other side of the x-axis. What if I wanted to draw pi over 6? Well, pi over 6 would look like what? It's taking pi and dividing it into 6 different units, so it would look like a rotation like this. Now let's change it up a bit. What if we wanted to draw the angle 3 pi over 2? Well, we know that 1 pi over 2 is 90 degrees. 2 pi over 2 is equivalent to pi, and 3 pi over 2 would be this measurement right here. Now, what if you wanted to represent the angle negative 7 pi over 4? So now we're going to go in the negative direction. And the easiest way to think about it is, what is pi over 4? Pi over 4 is 45 degrees. So if we have 1 pi over 4, then 2 pi over 4, right, is what takes us to the 90 degree mark. Then we have 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So if we rotate in the clockwise direction, basically until we get to the middle of that first quadrant, we have an angle that is negative 7 pi over 4. Another way you can think of it is divide 7 by 4, and that goes 1 with 3 remaining. So that means you've got to go 1 pi around, and then 3/4 of the way around of the other pi. Okay. So knowing radian measurement is going to be really key. The next video I'll show you actually how to convert between degrees and radians and vice versa, and also talk about a really important concept, which is that of the unit circle.